Hi, everyone. Welcome to Vijay Datta chemistry classes. This is Purnima ma'am. Today we are discussing a new chapter, chemical bonding. See the complete chapter on one of our subscriber has requested to explain the chemical bonding. So I started the chemical bonding. So completely I'll finish the chapter one by one video like. Please, before that, please do subscribe to my channel and please share the videos to your friends also who needed the understand the concept and everything. Please share to them and ask them to subscribe even to our channel also. Okay. See, today I'm going to discuss about the octet rule. Octet rule. Why I started this chemical bonding with the octet rule? I want to say. See, in the chemical bonding, we'll study different types of the bonds, that is ionic bond, covalent bond, coordinate covalent bond. We have a different types of the bonds. In that, first one is ionic bond, covalent bond, coordinate covalent bond. We have coordinate covalent bond, metallic bond, hydrogen bonding. So we have a different types of the bondings. Why one molecule is try to form a bond, first of all, that we should know. Why one atom it tries to participate in a bond formation. Why hydrogen should form a bond with the chlorine. Why hydrogen should form a bond with the hydrogen. How these molecules, H2 molecule, HCl molecule, individually hydrogen is an atom, and why it is forming HCl molecule like H2SO4 molecule it is forming. How these molecules are existing and what is why they have to participate in a bond formation. That is, everything will be surrounded with the octet rule. Okay, what is meant by octet rule? First of all, why we have to study this octet rule? Before going to the octet rule, we have to know about the Lewis dot structures. We have to know about the Lewis dot structures. What is the Lewis dot structures he has given? See, this Lewis dot structure simple. We have in a periodic table, we have a groups, first group, second group, 13th group elements, 14th group elements, 15th group elements. In the periodic table, we'll study their valencies and all. Like, see, first group elements means what? We have hydrogen, lithium, sodium, potassium, rubidium, cesium. Anyway, francium is the radioactive element. Comes to the second one. See here, beryllium, magnesium, calcium, strontium, radium. Come to the 13th group elements means they will be here. These are called S block elements. From here, 13, 14, 15, 16, 17, 18. These are called P block elements. And in between them, here one block will be there, that is the D block. And at the bottom, there will be two lines that represents the F block elements, right? See, once the elements what we have in the 13th group also. Boron, aluminum, gallium, indium, thallium. Come to 14, carbon, silicon, germanium, tin, lead. See, 15th group elements is nitrogen, phosphorus, arsenic, antimony, and bismuth. Come to 16th group, oxygen, sulfur, selenium, tellurium, polonium. 17th group elements, fluorine, chlorine, bromine, iodine, and astatine. 18th group, helium, neon, argon, krypton, xenon, and radon. See, in these elements, while studying the periodic table, we'll learn that first group elements, its valency is +1. Second group elements valency is +2. That is nothing but wherever we are getting that sodium, potassium, rubidium, cesium, okay, francium, you can leave it. Francium, sodium, it can have a charge of plus only. Potassium can have a charge plus. Rubidium, wherever we see, its charge is +1, like we can tell. Because how these charges are coming? Whenever we are saying beryllium, wherever you find the beryllium, if it wants to share its charge, what is the charge of beryllium? If we see, we can explain that as +2. Why and how? So we have beryllium. Whenever we see beryllium, charge will be +2. For boron, it is +3. For boron, it is +3. +3. Aluminium +3. So for 13th group elements, its valency is +3. Whereas come to the carbon, silicon, germanium, tin, lead, see they'll show +4 to -4 also they can show. Okay, nitrogen family. Nitrogen family have a capacity, it can show -3 to +5. -3 to +5. Variable valencies can be existing. So oxygen, if you see, -2 to +6. Whereas come to the 17th group, -1 to +7. 18, 0. How these valencies they came? Why for 17th groups -1 to +7? Why these have 0 valency? All these are depending on the according to the octet rule only. What is octet rule first of all? See, I'll take one element, sodium, suppose. What is electronic configuration for sodium? 1s2, 2s2. So sodium atomic number is 11, means it has 11 electrons, 11 protons. 11 electrons means 1s shell, 2 electrons completed, 2s shell, 2 electrons completed. So how many we have? 2p, 5. Isn't it? 1s2, 2s2, 2p, 2p6, 3s1. Because we have 11 now. 6 plus 2, 8 plus 2, 10. So 3s1. See, what is the outermost shell here? The last electron entered into which shell? That shell is called outermost shell. And that one electron here. In 3s, one electron is there. That one electron is called outermost electrons. Outermost electron. See, what is meant by octet rule or what is meant by Lewis dot structures? Lewis want to represent how many number of valence electrons that element has with the dots. Now sodium has one valence electron. So sodium we have to represent like this. Suppose see sodium, even potassium, that complete first group, sodium, potassium, rubidium, they will have one valence electron. So rubidium, cesium also will have one valence electron. That one valence electron he wants to represent with one dot. Whereas come to beryllium, beryllium belongs to second group. Once write its 1s2, 2s2. Beryllium atomic number is 4. So 4 electrons. 1s is called core electrons, 2s shell is called outermost shell, and it has 2 valence electrons. That 2 valence electrons will represent with 2 dots. That is called Lewis dot structures. Boron, atomic number is 5. We can write 1s2, 2s2, 2p1. But here, see, outermost shell is second shell. Here, in the second shell, how many electrons we have? 2 plus 1, total 3. So whenever boron you are writing, number of valence electrons on the boron are 3. Will represent like this. Lewis represented the number of valence electrons as the dots surrounded by that atom. That is called Lewis dot structure. Okay, now come to the octet rule. What is meant by octet rule? That octet is nothing but 8 electrons. Every atom, it tries to get stability. When atoms will get stability? When they have 8 electrons in their outermost shell, they are stable. That is called octet rule. Then what about hydrogen and helium? Lithium. Hydrogen will have atomic number is 1. Helium 2. Lithium 3. Beryllium is 4. How they can have 8 electrons in their outermost shell? They cannot have. That's why for these 4 elements, we'll check with the duplet configuration. Octet configuration, duplet configuration. Duplet means if they have 2 electrons in their outermost shell, they are stable. Helium 0 valency we said in the previous. Why helium here 0 valency? Because helium already it is stable with 2 electrons in their outermost shell. Because helium, its atomic number is 2. Helium electronic configuration is 1s2. It is stable with 2 electrons, duplet configuration is fulfilled. So why atoms they have to form a bonds? Because every atom tries to get the stability. To get that stability, they require 8 electrons in their outermost shell. To get that 8 electrons, they'll start bonding. Sometimes they lose the electron, sometimes they gain the electrons, sometimes they'll share the electrons. They only forming the bonds. If they lose the electrons or gain the electrons, the bond forming is called ionic bond. When they share the electrons, the bond forming is called covalent bond, ionic bond. Let us define octet rule with one example. See, I'll take NaCl. How NaCl bond is formed, let's see. Sodium, it is 11. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. It is its outermost shell. But when sodium will be stable, when in the outermost shell, it has 8 electrons. But in the outermost shell, it has only 1 electron. It is not stable. So there is 2 chances. Either it has to lose this 1 electron, loss of 1 electron, or gaining of 7 electrons. Which one is easy, students? Loss of this 1 electron, losing this 1 electron is easier. Actually, how we said 11 protons and 11 electrons, that atomic number means. If it loses this 1 electron, how many electrons in the, then a second shell will be the outermost shell. It has 2 plus 6, 8 electrons. Now, if sodium loses this 1 electron, outermost shell will be second shell that is stable with 8 electrons. So, sodium tries to lose 1 electron, then it will have 10 electrons. Who is dominating here? 11 protons or 10 electrons. Positive charges are more. That's why whenever one atom, if it loses 1 electron, it gets the positive charge. Now when compared with sodium, sodium plus is more stable because it has 8 electrons in its outermost shell. Now come to the chlorine. Chlorine, its atomic number is 17. 17 means its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p. See, 10 completed. 10 plus 2, 12. So 5. See, what is the outermost shell here? Third shell is the outermost shell. Third shell, in how many electrons we have? 7 electrons we have. Here also again the same option. Losing of 7 electrons or gaining of 1 electron. Which one is easier? Gain of 1 electron is easier. 17 means it has 7 electrons and 7 protons. Now to get the stability, it is gaining 1 electron. So it will have 18 electrons. Which are more? Positive charges are negative. Negative is more. That's why whenever one atom is gaining the electron, it gets the negative charge. Here chlorine is gaining 1 electron to get the stability. When compared with chlorine and Cl minus is more stable because in its outermost shell it has 8 electrons. This is called octet rule. Means every atom it tries to get the stability. How it will be stable? If it has 8 electrons in its outermost shell, it is stable. So each and every atom it tries to get stability. So according to that, it will lose the electrons sometimes, it will gain the electrons sometimes. So now Na plus Cl minus. This, they are the valency, it is positively charged, it is negative charge. Electrostatic forces of attractions between there for one cation and for one anion. So there will be a bond will be formed between these two. That bond is called electrovalent bond. That bond is called electrovalent bond or ionic bond. So which leads to form the bond to get the stability. So how ionic bond is forming? By losing the electron and by gaining the electron. So sodium ready to lose 1 electron. That 1 electron will be gained by the chlorine. So it is ready to lose 1 electron. Chlorine is ready to gain 1 electron. So whatever the sodium losing 1 electron will be gained by chlorine and bond will be formed between these two. The electrostatic forces of attractions between sodium plus and chlorine minus forms a electrovalent bond. This is called NaCl molecule. This is called octet rule. Octet rule have some exemptions also. In our next video, we'll see of exemptions of octet rule. Okay, guys, thank you. Limitations of octet rule also we'll study. Please keep on watching. Please do subscribe to my channel. Thank you. Thank you so much.